Hi, Algebra students. Today we're going to cover 8.7, sorry. You'll notice that I'm skipping 8.6 because it's just a little bit more difficult. So I'm going to do 8.7, 8.8, and then we'll go back and pick up 8.6. Today is factoring special products. So if you remember, when we were foiling a plus b times a minus b, the first would be a squared. The outer is negative ab. The inner is a positive ab. And the last is a negative b squared. What was unique about this is that these two, the outer and the inner, are opposites and they're going to cancel out. So we get a final product of a squared minus b squared. Okay, so let's take a look at what this is. First, it's a binomial, not a trinomial. There's a negative sign in the middle, and the first term and the last term are perfect squares. So a word that we have, or a phrase for this, is the difference of two squares. The difference of two perfect squares. So whenever you see the difference of two perfect squares, then we are going to factor this backwards. Remember, factoring is a lot like reverse foiling. So we would take the square root of the first term, and that would go here and here. One would be plus, one would be minus, and then the square root of the second term, and that goes there and there. All right, let's take a look at these. The first example is x squared minus 16. Okay, let's see, do we have it? Do we have a binomial? Yep. Do we have a subtraction sign or a negative in the middle? Yep. Is x squared perfect squared? Yep. 16? Yep. So the way that we're going to factor this is going to be the square root of x squared, which is x and x. One's a plus, one's a minus. And then square root of 16, which would be 4 and 4. And if you're not truly convinced, I would suggest, and you always can after you factor, to FOIL this back and see, do I get back to my original expression, polynomial? And you will. All right, here's the next one. 25m squared minus 36. We've got a binomial. We've got a subtraction sign. This is a perfect square. This is a perfect square. So the way that we would factor this binomial would be square root 25m squared. So we'd have 5m. One's a plus, one's a minus. And the square root of 36 would be 6 and 6. If you FOILed, you'd have 25m squared, negative 30m plus 30m. They cancel. And then negative 36. And the last example of this type, we have all of the conditions for the difference of two perfect squares. So we square root x squared, which is x and x. One's a plus, one's a minus. Square root of 49y squared would be 7y and 7y. Okay, so we're just training your eye how to recognize those types of polynomials. All right, sometimes you might get a binomial and there is a subtraction between them, but you go, oh, 8 and 18 are not perfect squares. Well, we might have to do a pre-step first, and that pre-step is factoring out the greatest common factor. So what is the greatest common factor of 8 and 18? That would be a 2, correct? So if we pull out the 2, then we would have 4 minus 9n squared. And lo and behold, now we have that binomial that is the difference of two perfect squares. So keep your 2 out front. Put down your 2 parentheses. Square root of 4 would be 2. One's a plus, one's a minus. Square root of 9n squared would be 3n. And that would be fully factored form. Okay, 4y squared minus 64. So this is a perfect square. That would be 2y, and this would be 8, correct? Let's do it that way. So if we had 2y plus 8 and 2y minus 8, this is factored. Now, if you were taking a standardized test and they want you to fully factor, that means that we have to, in each expression, we cannot have a greatest common factor. And notice that both these terms could be factored by a 2, correct? So we could pull the 2 out. We'd have y plus 4. Pull a 2 out here, y minus 4. So fully factored would be 2 times 2, which is 4. And then y plus 4 and y minus 4. So even though this is factored, if this were equal to 0, we could set each of these equal to 0 and apply the zero product property. But if we just wanted fully factored, this is the better answer. Now notice if we started up here and factored the 4 out first, we would have y squared minus 16, and then this would factor into y plus 4 and y minus 4. So just another way, I wanted to show you there's no right way or wrong way of doing this, but to be fully factored, there is no greatest common factor in any of the factors that we get. All right, the other special product is a perfect square trinomial. So let's go ahead and FOIL this. A plus b times a plus b. So a times a is a squared. The outer is ab, and the inner is also ab. And then the last term would be b squared. So when we combine like terms, we have a squared plus 2ab plus b squared. If they both had the negative sign, we would have a squared minus ab minus another ab for a minus 2ab. The last term is always positive. So why are we looking at these two? Well, we want to help ourselves out sometimes factoring if we can recognize that our trinomial is a perfect square trinomial. What does that mean? The first term will be a perfect square. The last term will be a perfect square. And the middle term will be twice the square root of this times the square root of that. Here, if your middle term is negative, then they would both have the negative. All right, it's not as complicated as it seems. And actually, this whole method is completely optional because to factor this, even if you don't recognize that maybe it's a perfect square, you can factor this the same way that we were factoring this before. But first, let me show you how to recognize this as a perfect square trinomial. All right, I have a perfect square. The square root of that is n. I have a perfect square. The square root of 36 is 6. And then I know n times 6 times 2 would give us a negative 12. All right, actually I have to be honest with you. I normally don't even recognize this as a perfect square trinomial. I would just go ahead and do n and n. Both signs are the same. They're both negative. Two numbers that multiply to 36 and add to 12, 6 and 6. All right. And then one option, when we have this, we could write this as n minus 6 quantity squared. But it's not really that big of a deal to write it like this instead of this. Okay. Notice here that we've got a 9. This is the first time that we have seen a coefficient other than 1 as on the leading coefficient. So it might help us here to recognize, oh, this is a perfect square. The square root of this is 3x. The square root of 4 is 2. 3x times 2 is 6x. Double it, and you would get 12. So this is going to factor into 3x. It's going to be a minus square root of that, 2. Okay. The last one, we have 4s squared. Ah, that's a perfect square. T squared, that's a perfect square. Square root of this is 2s. Square root of this is t. 2s times t times 2 is 4st. So this would factor into 2s plus t quantity squared. These are just hopefully helpful shortcuts. The last problem, whenever you have a trinomial and you have a negative, it's a leading coefficient, you always want to just pull that negative off front. So we're factoring, or we're dividing everything by a -1. So we would have 3y squared, whoops, this would be a minus 36y, this would be a plus 108. Well, 3 is not a perfect square, is it? Neither is 108. But I'm thinking, well, what if I factored off a 3? So let's pull out the -3. Then I would have a y squared. This is supposed to be -36 divided by 3 is 12. And 108 divided by 3 is, I have to grab my calculator. $36. And then especially since we're working in the section of the book that's talking about perfect square trinomials, we recognize, helps us recognize a little bit, this is going to factor into y minus 6 quantity squared, and then we are fully factored. And if any of this seemed confusing to you, I would recommend watching it again. Here's your homework, and I will load those on the Google Classroom. Hope you all are well. Take care.